It's a video in DraftScience. Yeah, I was just watching a holiday video, so it just sort of put me in the mood. It has lots of toys, and yeah, you sort of probably got to do more with them. Um, so I just thought I would do where we are in terms of how I'm rethinking things. And there was two concepts he brought up. One was conservation of momentum, which again I would argue that I'm certainly accounting for it in the sense that I'm basically saying photons are never created or destroyed, and photons are just changing direction, and so there's always the same amount of energy forever, except it will go away, further away from each other, and that we're just in this pressure gradient in the universe, and the pressure is gravity. And that all the real interactions of the real universe are like dominoes or like kinetic balls or like some other thing. It's all kinetic. There's no changing from an amount of photons to another amount of photons. What we see as energy is really the conversion of a bundle of photons into different bundles of photons. And one could understand that one group of fish going in one direction would would be less likely to provoke interactions, other events, other dissections. When something gives off more of something, I mean, when it breaks into pieces, more scatter. We call it that way. We call energy scatter. And that you could take one big bundle and you break it into 6 or 7 little bundles moving in a different direction. That's going to add more scatter to a system. It doesn't add more energy, it just adds more noise. And that's what we often see as a release of energy. And the energy was always there. It is a release in the sense that you're taking it from one bundle and reducing it, but the price of the reduction is scatter, is chaos, is noise. Anyway, so I'm not accounting for the conservation of momentum. I'm just arguing that momentum isn't really. Momentum is an illusion of the function of the bundle. So, like the school of fish analogy, when the fish are swirling in the school has no momentum. When the fish are moving more in one direction than any other direction, the school migrates, and the speed of the migration is related to what proportion of the fish are moving in the direction. So the more fish moving in the direction, the faster it will be going. It is the less of another motion it will be doing. And that, of course, accounts for time dilation and a few other things. So the other question was electrons, and my argument that they're eating space, that momentum is basically a function of something somewhere in the orbit of an atom that's creating this idea that somehow more fish are moving in one direction. Not a lot more, just enough fish to migrate the entire school in a direction. And so I've given a couple examples of how that could happen. So let's just start with the basic premise. For not something I'm arguing is proven or demonstrated in any way. I'm just going to argue this is like a way to start to build a model and say what's possible from that beginning point. So if we begin with the idea that all there are these little tiny bits, and they move in straight lines at the speed of light. I don't know if there's a symbol for the speed of light, but I'll just use that. Yeah, there. It's moving the speed of light in a direction, straight line, and that's all it does until it hits something. And it has to hit some specific things. It has to hit something. It can't, theoretically, that's one of the first rules we run into, I suppose, is that it can't hit something also doing exactly what it's doing, is moving the speed of light. Like light can't interact with light. Not that we notice. If it has an interaction, the interaction ends up somehow being like the head-on collision. And it's an interaction, but kinetically nothing happens. Something leaves in this direction, something leaves in that direction, and it looks exactly like it would look if they didn't interact at all, except they might be slowed down one Planck constant of time, theoretically. Yeah. So you have just these moving things. And so what do you say if these discrete bits can do? They can do this thing going from point A to point B, but what if they could also attach to each other? So what if they had a shape, like an arrow? Or something like an arrow. Well, here, just draw something arrow-like. It could be a diamond shape. It could be a lot of shapes. But say if something just a simple little arrow shape. Should make this stuff bigger. Well, you could see that the arrows could fit inside of each other, maybe, and they'd be stuck to each other. And so you could say, okay, that's understandable, that they would be connected. That if they incidentally hit each other in just the right circumstances, like two of them come at each other at a 45-degree angle or something, and in the right conditions, they meld into something that connects, and that the more they connect, the more likely they are to collect connections, we could argue. And so that you could have a shape that would be a shape of photons that had no frequency. So they were connected so tightly together that you wouldn't notice them as having a frequency. So they wouldn't appear like the normal electromagnetic spectrum of photons. They would instead be some other kind of machine, some other kind of mechanism. And then if you just take that idea and create this idea of a pressure gradient and all this other stuff, you could probably say that there is a mechanism, in the universe and suns and something that obliges these straight lines to turn into circular lines. So they're connected in such a way as they become a circle. Now, that creates problems, right? It's what's holding the circle together, what's forcing the circle. You could say if the two ends are connected, then Hoffaday is correct in that it's hard to make this into some sort of shape in space, so you can make it some lopsided shape of an orbit, let's say. And well, the fact that they're moving the same speed all the time, you could argue that this shape, although it looks like it should go this way or this way, might end up going this way. Just because it's the only thing that would dictate what direction it goes in is how much distance, the photon travels in different parts of that orbit. So the less time it spends would mean there was less movement in the lateral direction to whatever that smaller point would be. So it would tend, if it was spinning clockwise, say this way. The fact that I'm not doing these drawings very well at all. The fact that if it was spinning this way, it would tend maybe, if this electron thing, this snake was spinning this way, it would tend to spend less time in this, doing this direction here, and more time doing this direction. So the fatter end, it would spend more time going that way than it would spend going this way. And so the amount of time, the more distance, the more time you would spend in a certain direction. So the more time you're going in a certain direction would equal a tendency to move in that direction. So this shape would end up moving like this, like in a direction consistent with its orbit. That's one way to account for it, I think. Another way is just to have an opening somewhere in the circle. and that automatically, in the orbit, that would automatically give you this eating thing, where it's biting off space in every direction. And so any ellipse in the direction would automatically create a tendency to eat more in the direction of the more distant side. So whatever these two sides would say be equal overall, but these two sides wouldn't in terms of their distance. So there would be a tendency to be eating more space in this direction if there was an opening here in this spin. So if you had an opening, it would end up eating more direction in this fatter end. So this fatter end, it would end up moving like a paramecium backwards, the fat end first. Yeah, so this isn't exactly how I want it. Well, of course, it never goes exactly the way I want it to go. But the theory is that the argument I'm going to make is that everything that is held together is being held together because there's a constant stream of gravitons, photons without any frequency also. So photons can have no frequency if they're connected to each other, but they can also have no frequency if they have no pair. There's just one photon, and it doesn't have another photon to create its frequency. So it has no frequency between incidents. They're not coming in a stream, a stream close enough in directionality for them to have an effect on an electron in a specific way. So gravity would be the opposite of, say, this. If we call this the electron, the connected together photons, because we sort of know that electrons have a mass. I mean, they have an energy level that's would equal a substantial number of photons. So it seems to me logical that electrons are not a single particle, that they are in fact a stream of particles. I think it would also see. Yeah, I can't say it for sure. So I mean, theoretically, electrons could just be a bunch of photons that have stuck to each other, and they're just clumped. They're just in a ball. And we're back to the fish argument. What are they? How are they collectively moving? So they can be spinning around each other and moving in a direction just based on what pattern is in that swarm of electrons. I mean, that swarm of photons. So the individual photons are all still moving the speed of light. They're just doing it in patterns. So it's almost like a plasma or something. You can imagine something that's just, it's always in motion. And so the interior of the electron is always in motion. But it has a directionality because a substantial portion of the electrons end up moving in a specific direction. So they're moving, and that creates the idea of them having a speed, and just like gravity, they would be pushed into this, being pushed to the center. So, Hathaway did some illustrations of Einstein's, bent space thing, and like I said, it's just a convergence. I mean, that's what you call it. The idea is that there's a consistent flow in a drain, and the drain just keeps, it goes out. It's just constant. It's a constant flow. The pressure never rises, never falls. It just constantly flows from an infinite source to an infinite conclusion. And obviously I have a problem with this idea of, infinite drains and infinite waterfalls filling the pool. I mean, it's not very explanatory, as Hathaway would say. It doesn't provide much of a explanation for the mechanism, where if you create some sort of pressure system, forcing everything to clump. And, I guess that would be the tendency. If there's always something banging around things, and always creating this idea that if there's, again, we'll go back to the visual is, that's a great circle, huh? Yeah, wow. I did have a stroke a few years ago, but man, that is just pitiful. Okay, the idea that these two incidences, would cast shadows of pressure. So if there was photonic pressure from all directions, and this would block the pressure from this direction on this object, and this object would block the pressure in this direction on this object, and so the tendency would be that the two objects would be forced together. So that's we could say that was the fundamental principle of everything that's happening in the universe, is this principle, that there is in fact a directional information. That's what we could call it, graviton. It's a directional information, because it's not in a form that's capable of converting into energy. It's the simplest thing. It's just a single photon moving the speed of light. And so it has no ability to split into, you know, to arrive somewhere as 4 photons and leave as 2 and 2. Like, for example, ultraviolet light turning into 2 packets of, let's say, infrared light. Yeah. So this is maybe the key. Like, if there was one single thing that was just, this has got so much explanatory value in it, it's this thing. Because this does the, you know, it's the same relationship for gravity and magnetism, and the nuclear forces, I think, can be explained by the same mechanism. Once we can, and I guess you can do it mathematically, once you can establish the actual masses of the objects. We can't really do that explicitly, and that's probably partly why we probably can't apply a formula to something where we can't exactly measure by any real quality measurements sizes, you know, masses. But it's probably, who knows, it might already be something that's indicated in physics. I just don't know all those equations, so I don't know that for sure. So anyway, this just isn't, just isn't doing what I wanted to do. So anyway, so that's the mechanism. And so all we're really, if we can start with the simpler item, like I said, the bigger item, you know, where people find some problem with this idea of shadowing pressure, photonic pressure, because they think it'll create heat and they think it'll create friction. But the thing to remember is that the atom and its nucleus is actually in the same exact universe that the big objects are in. And that these big objects, these celestial bodies, you know, hugely bigger than this atomic body, they're in the same space and they're in the same photonic pressure. So it's the same mechanism, and the difference is this thing is made up of zillions and zillions of these smaller things. And so it's the pieces that are really doing the action. So almost like you could say, if the electron was a school of fish, you know, this is an even bigger school of fish, an even bigger school of fish made out of schools of fish. So the individual fish, and then, you know, is a school of fish, and then you can just zoom out and try to visualize that school of fish is in a grouping of schools of fish, and they all have their individual motions, but it's the same rules as the school of fish. And then you can zoom out again, and it's even bigger. You know, those bigger schools of fish are swarming around inside of a bigger school of fish, but they're all obeying technically the rules of the smallest fish. The smallest fish are the only real fish. The other schools of fish are an illusion of function or physics. The real physics is all nuclear physics. You know, there's no, so when I say there's no such thing as momentum, you know, what I'm arguing is that momentum is an illusion. It's just a preponderance of the nuclear forces in a direction, the nuclear fish moving in a direction, that are creating the illusion of momentum. But there's no real momentum. in the sense that we're just talking about photons moving in a direction. And whether they're moving in a direction or standing still, it doesn't matter to the photon, because the photon's always doing the same thing. It's always just moving from point A to point B at the speed of light, and all you're doing is changing which direction it's going in. So there's no energy difference between, you know, the school of fish in one place and the school of fish migrating. And the migration only means that you have to change the directionality of the school of fish. So it seems like you have to apply energy to change the direction. But theoretically, all you have to do is, that's the right way to say it, the energy you put in will come out. So it's not like you're applying energy. You're not adding energy to stop it. You're not giving it energy to stop it. You're having to use energy as a supplement, as a replacement for the gravitational pressure that changed the orbits. So the orbits have all been altered. So now we're eating space. The matter is eating space. The atoms are eating space in a certain, tending in a certain direction. And you're going to have to use energy now to change that distortion. So you could argue that gravitons change directionality. When they go through you, they maintain a directionality. They maintain a directionality pressure. So if I'm in a gravitational shadow, there'll be more photons pushing's the wrong word, be more photons changing the directionality of my electron photons, the photons in my electrons. They will be tending them to move in a direction more often. And that creates the illusion of acceleration. It creates the reality of a preponderance of the photons moving in a direction. And to change that, if you don't have gravity, if you can't find some gravitational pressure to change it, you have to change it with some other form of photon. So you can throw some other kind of photonic energy at something and create the illusion, the same effect as the graviton pressure. So in a sense, the material pressure of the earth below me, the fact that the electrons and the atoms and the photons are all under pressure below me, is essentially creating another photonic kind of force that's pushing me back up. So as gravity tends to make my atoms go in one direction, the force below is pushing and therefore tending to change their orientation back to a neutral position. So I'm just basically being bounced up and down by those two competing circumstances of pressure. One created by gravitons and one created by electrons. Yeah, that's probably not an unreasonable way to say it, but they're all photons. It's the photons in the electron that's creating the pressure, pushing me up, and it's the gravitons of the cosmic pressure that's pushing me down. Yeah. So anyway, but it's all the same pressure, and it's just a difference in terms of how many layers of schools of fish you have. So, you know, you could do it like almost a cellular organism. You could argue that biology is sort of mimicking this circumstance, where we're made out of, you know, first chemistry, but let's just say a cell. And so you start with a cell, and then we're a collection of cells in an organization, and then you could almost argue that a society is a collection of these organized packets of cells that are again organized into a kind of organism. Obviously it's going to be difficult to synthesize a brain and organs and all that stuff in a society, but you can sort of get you get a much cruder idea of it. Is then you have industry and you have services and you have hospitals and you have this and you have these different mechanisms of the society that would be like the different organs of the body. But you're probably not going to be able to like I said, create something as bizarre as the synthesized thinking machine that's created out of our cells. Yeah. So yeah, we have we've called these things the same thing, right? A single cell we call a life form, and then we call ourselves a life form, but they're really not the same thing. They're made out of the same thing, and just that's the same kind of thing with physics. Yeah, the nuclear thing and the material thing kind of need to be understood as being they're obeying somewhat different rules, but ultimately, just like us, it's the cellular and the material, chemical reality that creates most of them, that creates the illusion of our organization. It's really doing the work. The work is really just chemical, and then you could argue the work is really just physics. Yeah. So you can sort of see that in science. They've all been separated. So you got cosmology and biology and chemistry and physics. So you have these disciplines, but they're really all in this, they're all just manifestations of the same nuclear universe. So physics is really the only real science, and the other ones are just acknowledgments that multicellular organism is very different in terms of it has new potentials than the cruder and simpler cellular machines. It's an added layer of potential. So the added layer for us would be something like momentum. Momentum would be a layer of functionality that is created when you take those schools of fish and make them into a school of fish. But it's, if you really look at the physics, if you go back that one stage, there's no real momentum. There's just a change in direction of the movement. There's a different designation of point A and point B for the photons that are traveling. So instead of doing this pattern, they're doing this pattern. So anyway, yeah, I probably should just hang up while I'm dissatisfied. I don't think it was useless, but it's just so that's what's just been rolling through my head is this. I really do need to come up with a more solid mechanism for these origin bits. But the idea that they're held together, that vision of the molecular nucleus, the atom, not being like a solar system, but definitely being like it in the sense that it is photons that are constantly banging into the parts and giving you the sense of them being held together. They're held together because they're being pushed together. Their space between each other is being compressed because there's a force that keeps pushing them into each other. For the same reason that gravity works. It's because once this bit is formed, once you connect two photons to each other, they're capable of blocking a photon now. Kinetically, they become a different instrument. So if some photon hits this photon, instead of breaking this apart or doing something, it's going to create a spin in this mechanism because it's now putting a certain amount of speed of light kinetic energy in, but the bond here will now transfer that energy, half of it, into this bit. So this bit will spin this way instead of traveling in a direction. So if this thing originally was just two photons connected to each other and they were both going that way, and now they collide into a single photon going this way, you can sort of understand that when this interaction takes place, it'll either hit this photon or this photon, and this directionality will end up being a spin rather than being leaving and going point A to point B at a certain speed. Now they've lost their speed in the sense that they still have their speed. They're still spinning this. They're still moving the speed of light. They're just moving the speed of light in this coil, which will now consume, in a sense, will give you the illusion that their speed is slowed down, when all it has been is it's been rotated on an axis. So now they're just like I'm vibrating on the Earth, and as I vibrate on the Earth, and the Earth rotates, technically I'm traveling much faster than the surface of the Earth because I'm going up and down the whole time. So as I vibrate, I'm traveling a much longer distance, which means I'm traveling more distance in the same amount of time, which means I have to be going faster, technically. My atoms are going faster than the surface of the Earth. Yeah, which is, it's, and that vibration, isn't that the nature of this creation of a sine wave, right? It's just a vibration in a moving plane, and then you're all of a sudden start creating what people call waves. And waves are just a manifestation of this, the tension of association. The fact that I am being pushed into something bounds me to it, creates the glue, the tension that creates the opportunity for this rebound effect. What else do I want to do with this? So anyway, yeah, so I guess I'm just back to this idea that there's a simple mechanism, and so then once this is spinning, it might be easier to hit it, and that way you end up with 3 pieces here or something, and then 4, and then 5, and then 6, and it ends up being some sort of construction, like one of Hafladay's toys, some sort of, thing where a bunch of crap is going on. All the pieces are moving at the speed of light, let's say, but they're all moving in very eccentric and different patterns inside of each other, even, and that's but once you create that thing, it becomes a thing that will be changed as the photons keep hitting it from all directions. They will keep knocking it back and forth and applying pressure to it and wobbling it, and if there's any differential in that wobble, it will tend to move in a direction. I would think even his machines, any kind of lopsidedness in the contraption, in the way it flips and spins and does its thing, any eccentricity in that could end up over time having a probability that it will flip more often in this direction than that direction, just because of the way the ineccentric, uncircular thing was created, the lopsidedness. So it's just like having this pen and just moving the center of gravity over. I'll create a wobble in its orbit and its spin, and that wobble will oblige it to tend to move in a direction. It will at least tend to make it wobble in space, and then all it needs is some other distortion, for any distortion, any other distortion, to create the idea of moving in a direction. But it's the eccentricity of it that gives it the perpetual capacity to do this spinning, but rolling as it's spinning. I gotta still work on that part. But I think it is explained by ellipses. And I think the important thing to understand in a nuclear ellipse, or an electron ellipse, is that speed can't be changed. So you can't balance the difference by altering the speed. So in an Einstein ellipse, let's say this was the sun, and something spinning in gravity around that sun, there would be an increase in speed here and a decrease in speed here. That would compensate for the energy difference, for the fact that this one's going greater distance. So the extra speed gives the lesser distance greater force, and the slower speed gives the longer distance less force overall, to balance the two ends. But in an electron that wouldn't happen, so speed would always be constant. So there'd be a clear difference in the amount of distance being traveled at the same speed, which means there would be a force difference, which means it would likely have to move in one of these directions. It would have to wobble this way. Yeah. Something like that. Kind of sure. I don't know. But then you have to explain the relationship between this center of gravity. So remember, this is all also being produced because there's this constant pressure. And the gravity between this body and the orbiting body is also going to have to be accounted for as you start moving this. If you change this orbit slightly and change this orbit slightly, you have to account for the fact that there's going to be stronger gravity at this narrow point and then weaker gravity at these wider points. And so I have to account for all of that, which gets complicated. But the idea would be is this wobble, this tendency to move in a direction, would likely drag this nucleus with it, theoretically. It seems opposite. I mean, it seems as the orbit would change, it would tend to do exactly the opposite. So again, I'd have to account for a relationship between a nucleus and an electron that has to be different. And it likely is. Like the electron having the constant speed, maybe there's a... I mean, you can account for this speed change by just saying the electron spins less. You know, the idea that the interior of it moves less. And that moves more. So the more it moves, the slower it goes in a direction, the less it moves, the less extra pattern it has inside of itself. Yeah. But the relationship, likely, I guess I could say as a theory, that there's likely a relationship between the nucleus and the electron that so we can say that because of this photonic pressure, there's constantly a wobble going on, a directional change in all directions, constantly vibrating. And that the relationship between this nucleus and this body is also now would have to account for the fact that once its orientation is changed, once its shape is changed, it stays in that changed shape until something rechanges it back again. So if they're in equal pressure, it doesn't matter what shape this thing is in, the pressure won't change it as long as the pressure is equal. It'll just stay in the new shape until something pushes it back into the right shape. But it's somehow a shape change in this atom that causes the atom to move in a direction. And it's really your atoms moving that creates your motion. Your atoms aren't really pushed. Their direction is changed. They have to move by a mechanism. I guess I shouldn't say they aren't pushed, because they can be. But once they're pushed, they're misshapen. So it's like if I pushed on a round circle and from a direction, you could tend to think that I would misshapen the circle, that I would flatten that side of the circle. And so now the circle would spin with one flat side, let's say. And so that would be something to account for. What would be the effect of that lopsided circle? And how could it restore itself in a kinetic world? So, where there's just the same pressure being applied, how can the same pressure reshape that circle? You'd have to add extra pressure somewhere to reshape it. Yeah. So that's the illusion of the world we live in, is things are reshaped. Circles are reshaped. But they're only reshaped because we're talking about the elastic tension between atoms, which is a nuclear connection. And so we're not understanding, we can't, it's not hard to visualize, but that's not empty space anymore. The atoms exist in this empty space universe where there is no glue. We live in the part of the universe where these arrangements, these shapes and patterns can kind of glue things and connect things to each other, where an effect on one is going to affect the other, is going to affect the other, is going to affect the other. Where the interactions with photons are less capable of affecting the other. Okay. Yeah, well, like I said, this wasn't exactly didn't really nail this one exactly the way I want to. Well, anyways, I'll do some comments real quick because they're just so lousy. So this, I just blocked this asshole. He's on my other channels too. He's just a snarky jerk. Yeah, you are smarter than Richard Feynman. That's not the argument at all. And so, yeah, you're saying Richard Feynman was infallible. Couldn't have possibly made a mistake. Not possible. Oh, he's God. That's why you live in a shack in the woods and men. We have what irrelevant. Like I said, Einstein was a patent clerk, while Feynman only won the Nobel Prize and taught at Ivy League campuses. So again, well, there's just no point, right? I mean, there's all kinds of people that had great credentials and they turned out to be liars. Richard Nixon, I could go through. Richard Nixon was president of the United States. Well, obviously that didn't mean shit, did it? It is possible for a working physicist nowadays to know a bit more than Feynman did. Yeah, well, that's almost a problem, though, in my opinion. Just because now they've got wrong premises, and now they're just using technology to synthesize what they want to see. For this to happen, though, you would need to be at the cutting edge of modern physics. Well, I guess what I'm arguing is that the mistakes were made in the origin of the theory. The theory was developed incorrectly. The model's wrong. And that's why they're coming up with these bizarre bent space arguments and force arguments that don't have any physics in them. They're just magical forces, right? I mean, I just think this idea of a material gravity makes a hell of a lot more sense than the immaterial space just happens to be a medium that we can't possibly in any way establish the mechanism of its knit. It's a fabric made out of no thread. In any case, any physicist would give credit to Feynman and other great physicists of the past, acknowledging their contribution to what we know today. Well, again, I'm just saying, you could, you want to say some great philosopher writes a great poetic rendition of Jesus Christ's suffering. It's still wrong because it's based on a wrong premise. Again, I'm not going to argue that Feynman didn't do some great math and he didn't do some great analysis, but he really sucked at models, in my opinion. And he had it in his hands. I mean, Feynman was really close. I mean, he even said it in videos. He talked about the checkerboard thing. He said explicitly, when I say photons move from point A to point B in a straight line, Feynman said those exact words. So he had already debunked quantum mechanics as modern quantum mechanics is talked about. Even in his day, he was debunking the two-slit experiment because he was basically acknowledging that the photons aren't doing anything. There's no wave on the photons. The photons aren't waving, they're not doing any of that stuff. They're interacting with electrons, and it's the electrons moving that's creating the illusion of wave mechanics. So he was already there, okay? And because he was just caught up in the magic of mystery and doing a magic show, he didn't say what was the truth. And like I said, I mean, in this video, I'm pointing out that he even in his lecture, he basically just lied. He talked about top surfaces and bottom surfaces and refraction, and he wasn't even explaining it the way it really is. There is no top surface and bottom surface. There's a medium, and as the photons travel through the medium, a certain percentage of them will end up refracted based on the distance they're traveling. the more they travel, the further they travel, the more likely it is for them to encounter something. The deeper you go into the forest, you have to break a certain amount of probability not to hit a tree. I mean, you can go a mile into the forest and let's say you have a 1% chance of hitting a tree. Well, yeah, if you go 10 miles into the forest, well, now you have a 10% chance of hitting a tree. That's not an argument, dummy, that's for sure. Gary, compare this guy's being rude with me being rude. I, too, could actually be offended if I'm judged unfairly. I don't know which guy you're talking about, the guy calling this a dummy, because this is a dummy argument, isn't it? Huh? I mean, was this this was a reasonable analysis of my video? This was just a defense of the Lord Feynman. So anyway, here's another one of his snarky comments, I'm sure. I'm sorry, Gary, I didn't see how I was rude and don't think I'm wrong at all. I'm wrong still. Well, I guess I don't know. That's being pretty rude then. Okay? Why don't you just Google, okay, I'm not going to do, you're expecting me to be obedient to your bullshit? Just Google electron microscope and two-slit experiment, okay, and you'll find two-slit experiments with slits that are 70 nanometers thick and a middle impediment that's like 100 nanometers. Believe me when I say that I'm trying my best to be as factually accurate as possible. I mean, if your best is you can't even bother to Google electron microscope and two-slit experiment, I don't know. Your best kind of just plain sucks. Because you're arrogantly saying, I'm not wrong. Yes, you were wrong, okay? The two-slit experiment has been done with micronic slits. They're not bigger slits than the one-slit experiment. However, I have to weigh this with being concise because you don't seem to devote an awful lot of time or attention span to individual remarks. Well, you don't watch my past videos. I actually did a whole commentary in one of my videos on the electron microscope two-slit experiment and pointed out the flaws in the way the experiment was done. What else can I say about your detail? I've talked many times about the needle. Well, he's going to do that now, so I might as well wait till then. For example, when I linked a short video giving you a means to replicate the two-slit experiment, I don't need a means to replicate it. I've seen it replicated lots of, cheap ways, and I'd rather do it well than do it sloppy again. It's been done sloppy lots of times. I think it needs to be done well. For a few bucks, really, you said, I don't watch the video till the end. Well, I didn't watch the video till the end. I don't know. I didn't say that. That's unfortunate. I don't know what it means. Oh, the one, yeah, well, I did watch it a second time, and I was completely correct. Okay, you're talking about the polarized filtered one. I mean, just horribly sloppy experiment. They never even took pictures of the polarized film in 100-degree positions. They should have just moved it at random positions at different angles and see what kind of effect they got. No photographs of any of that stuff. I'm thinking there's no photos because they would have demonstrated that those photos looked exactly as bad as the other photos. Their experiment was really quite sucky. You don't tear holes in a piece of paper and say I'm doing the two-slit experiment with holes that have ridges all over them. Now I need to say that this is sort of important, right? Because when you think about it, how much would the two-slit experiment be changed based on how many convolutions you create in the surface of the two slits? I mean, it could easily be argued, just like with electricity, you change the electrical potential, when you create these surfaces. So in electricity, these kind of surfaces will completely change electrical potential and increase the likelihood of a spark gap, where a smooth surface would have a different effect. So you can obviously understand that if there's a certain preponderance of interaction, that you're increasing the likelihood of interaction with a surface if you have more surface in a given density. So you're maximizing diffractability by not having a straight cut. So I'm, like I said, tear it. Actually, they did it with a pen. They tore the slits in the paper. Come on. Now, I need to say that the so-called two-slit experiment works with a pin centered on the beam instead of slits in the material. Yeah, and the question would be is, let's do that in a lot of different ways. Let's do that with single photon stuff. And if that's true, again, see, well, here, I'll just finish his comment. How is your theory faring in that case? Bouncy, dancy around it? You can't replicate this at home. You can replicate this at home too. Like I said, I've done it, okay? I've got needles right, look. They're in the eraser, okay? I've done it. You can also do two needles closely together and create more effect. My argument isn't that, see, you're basically saying that, you know, when there's an impediment, let's say a needle, okay, so there's the needle and the light comes in, you're saying that it's bouncing this way and bouncing this way. No, are that it's refracting this way, you know, they're just bouncing here and then going this way, you know, that there's a reflection. I'm arguing that these are electron interactions, and the fact is that these electrons are around the entire surface of the object. And so light will be bent in the illusionary sense that if the light comes out even this far out, it'll hit the static electrons that are around the object, especially a metal object like a needle. But anyway, it doesn't really, I don't know if that really matters. And the point is they'll be pulled in. Okay, so there's just as much likelihood of it being pulled in, you know, curved in, as there is likelihood of it going out this way. And that's dependent on the mathematics of the relationship between photons and electrons. So there's a certain clockwork to the exchange of directional information between photons and electrons. So when a photon interacts with an electron, it doesn't do some, you know, perfectly analog reflection. It does reflection based on the electron it's hitting. That's why they can use bands of light to reveal what kind of material. You know, you can cook a material and the light it gives off will reveal what kind of atoms it's made out of. Is because only light will be reflected, deflected at certain angles and at certain wavelengths. And so that specificness of electrons, the fact that it will only produce certain reactions, it won't produce an analog answer, it'll produce a digital answer of certain all or nothing reactions. Okay. Also, you keep describing experiments that you claim have been done without providing references. I don't know what that is. Experiments I'm claiming have been done? I don't know what you're talking about. But when people do the same and provide links and papers and such, you dismiss them. I don't dismiss them. Every paper I've ever gone to research hasn't been what the person said it was. Okay, so is that my fault? And frankly, I don't see what paper you linked to that was disputing anything I was saying. And, again, you're the one that was wrong. And you won't even admit it. You're wasting my time. You're telling me I am going to have to prove to you. Okay, then you're not going to prove something to me. You're telling me I have to waste my time proving to you that the two-slit experiment was done with an electron microscope. I shouldn't have to do that. Because the fact of it is easily ascertained. It's either, I mean, like I said, I did a video on it, jackass. This has not really been done, has it? Yeah, it hasn't. I don't know what that means, but I don't care. Take care. Yeah, well, fuck you. Like I said, you're not arguing the points I'm making. You're arguing from authority and, you know, Wikipedia. And it's just not my obligation to, you know, explain in detail why their experiment isn't demonstrating what they claim it's demonstrating. I mean, really, is it? Because if that's the way it's going to work, every two-slit experiment, the people doing the experiment write up a whole paper about what conclusions they draw. And I'm frankly, every single one of those papers I could probably dissect and find kind of gross mistakes in the conclusions drawn. Should I just waste my time doing that, or shall I be busy about proving my own theory? Yeah. I think I know which one I'm going to do. So, fuck you, I'm going home. Such. Sorry, like I said, it wasn't as good a video. It's a nice mess on the paper. But yeah, it wasn't quite as good as I wanted it to be. But, you know, try again next time.